Hello and welcome to Go Guild. Welcome to the Go Guild in October. Lots of announcements today. Not much going on in the Go space this month, so let's get into it. 123.2 is released with some fixes to the compiler, some runtime fixes. Nothing too feature rich, but nonetheless good to be secure. I was reading an article on sync.map, and I'm sure a lot of you are aware, but maps aren't concurrent safe. So in favor of using, we could either use a sync.mutex or otherwise we can use a sync.map. Sync.map is really good because it allows for sort of read heavy scenarios. You can see on the right here that the internals of the sync.map, we've got a dirty, or what they call a dirty map, and a read map. So the dirty map stores new entries, whilst the read only is used for lookups. So next time you're using a sync.mutex or a sync.map, always consider what you're kind of using it for. If it's read heavy, sync.map, great. But mutexes are always going to be good for kind of write heavy scenarios there. You can see the difference between mutex and map here, map on the left, but both have their trade-offs, and both work as good as each other if you're working with maps concurrently. David, you mentioned last week I was about SQX and Squirrel. So I think it was the last time I was saying that I was working on a side project with SQL-C and Docker tests. This is kind of another route to use databases in Go. I'm pretty sure everyone's heard of SQLX, but really good library for interacting. It's got, Postgres support, native standard library, stuff like that. And then Squirrel, I actually haven't used, but really good kind of query builder for anything you want to use. So that's those two tied together makes, again, query building really easy and lovely. This is something not directly to Go, but I kind of wanted to touch on it. There's been a lot of noise about WordPress recently in the news. TLDR is the kind of WP engine that owns a plugin called Advanced Custom Fields, have actually been banned from WordPress. I don't want to go into the legalities of it. It's a bit of a hot potato, but it's kind of interesting to see. And we might see kind of a shift for people to using headless CMS systems such as Payload and Strapi. And I certainly think that the Go ecosystem is missing kind of a rich CMS library. But very interesting topic. And yeah, quite controversial. Errors.join. I actually haven't seen errors.join, but when having a look for the notes of this presentation, can combine multiple errors. So you can see kind of separate error messages when you start to unwrap them there, and you loop over them. I don't know a good use case for this, but nonetheless, there's a really good article there at the end. And when you're traversing those errors, you can use errors.is, errors.as, which is really, really cool. So that's a good one to have. Go mem limit. So maybe you don't have a memory leak after all. So Go has Go's default garbage collect behavior rather to leak. So if you've got a kind of a small VM with really small memory limits, you might be hitting that Go mem limit env arg. So it can really help you manage to, or increase it. You can literally set it by just exporting the variable. Good to play around with, and yeah, preventing OOM errors. But it's a good one to know about because one on the right there, we've got a runtime mem stats, which is quite a good flag to get it. Go pretty. It's just a. You can just dump data on it and it looks pretty. I need to say more. You give it a struct, give it a slice, and it looks really pretty. So if you're debugging stuff, instead of your standard fmt.print lines, yeah, go nuts on Go pretty. Looks really cool. And last one is a library that I found, Go mod view. really cool for kind of visualizing your dependencies, and it gives you this is a GIF from the repo, but you can actually kind of zoom in and play around with it and see what's importing stuff. So I think this might be a really good use case for like if you've got import cycles, and you can really see, okay, well, maybe if I put that interface there, or maybe if I change that struct there, be a good opportunity to see exactly where and how those dependencies link together. But yeah, really good library. So onto our knowledge share for this week. So we have David Godwin, and he started over in Jet Connect grocery space in May 2023, making absolutely massive strides up the engineering ladder. Been working on substitutions, and I know that he's got a really, really good story for us today. So David, over to you, mate, and good luck.
It's like a once upon a time moment now. Right, I'm going to share my screen. And Ainsley, when I press play, can you just tell me that you're seeing the actual slide rather than any notes and stuff?
I am indeed, mate. Yeah.
Marvelous. Cool. Hi, everybody. Yeah, my talk is entitled From Perfection to Pain, How Passing Tests Still Caused a PI. It could also be called What Does the JSON Marsher Do? But How Passing Tests Cause a PI is a bit more of a catchy start. So that's what we're going to talk about. So yeah, Ainsley mentioned, yeah, my name is David. I'm a software engineer at Jet Connect. I've worked at Just Eat for over a year and a half now. And we're in the, I'm in the Jet Connect groceries team. And that team, for those of you kind of interested in the organizational structure of where we are, we're in Jet Ventures, which appropriately with the rocket symbol there and the astronaut's hat, we're all going to Mars. The kind of point of the groceries team really is to try and scale groceries out at Jet. So that means building feature sets that allow partners in various different countries to sort of onboard to and integrate with our platform such that they can receive orders from customers. That is that. So today we're going to just kind of talk through 4 sections. Very briefly going to talk a bit about a feature that we built in groceries. It's called integrated substitutions. Then we're going to talk about how we tested integrated substitutions or a component of it, what broke when we did that, and why those things broke, and then kind of end on a sort of practical tips, sort of takeaways from this that might be useful to people. Right, so for the first step then, integrated substitutions. So what does integrated mean in this circumstance, for those who don't know? So integrated basically just means that rather than stuff going to OrderPad, it's actually going to a partner's own sort of picking device and system. So very sort of simple view here of the sort of ordering flow. Have a customer on the left there. They're placing a grocery order for some broccoli and a baguette. And it goes to Just Eat's backend, and then via a series of hops, it arrives at the Jet Connect system. And we then send that order down to a partner, and they use their own devices. They're going around the supermarket to pick the stuff. That's all well and good. If everything works, they've got everything in stock, they give it to a courier, and the courier helpfully goes and delivers it to the customer. But what happens when the grocery partner doesn't have the bread? How is it that they can communicate that to us? How is it that we can do refunds, or that they could perhaps adjust the order such that they provide, say, rather than a baguette, they could provide a loaf of bread instead. So we've built this so-called integrated substitutions, which allows a partner to say, here are the things that are out of stock, and here's the stuff that has been substituted in its place. So let's do a deep dive then into the architecture. Might be a bit small for you there if you're in the back. I'm not going to go through all of it. I'm going to kind of do a little bit like what we did, which is just kind of a very simple view of what it means for a partner to be able to do substitutions. So the partner, they're going around the store, they're picking something, they can't find the baguette. So they then get in touch with Jet Connect and say, hello, I've done a replacement. I've replaced the bread with something else. That's great. We say, thanks very much. Then we go off and we take the request and we go and ping a couple of other teams at Just Eat, and we say, you need to know that something has changed in the order, and you need to go and do things like menu updates or some refunds or update some reporting and stuff like that. There's some kind of processes that happen as a result of it. All very well and good. I'm now going to kind of show a simplified demo of how it is that a customer, a partner, could come to us and say, here are the changes that have happened. And then we take that information and then we craft this request to Just Eat to say some changes have happened to the order. So let's get on with it. So here is some code. At the top here, we've got a struct. It basically describes a change to an order. So we provide an order ID, we say the thing that was removed, and then we also provide a slice, points to a slice of stuff that was added in its place. Here we've got a function called send change. It takes in some information and it goes and calls an API. So we set up a substitution. We, in this case, have decided to make the order ID and the removed item ID uppercased. And then we go off and we go and do the request. And so in this case, what we've done is we've just done a very small sliver of the functionality. We're just allowing a partner to say, for this order, this thing was out of stock. Got that written now. Now we want to go and test it. So that's kind of what we're going to talk about. How did we actually test this stuff to make it consistent, make sure that we were happy with the behavior? Here is the test that we wrote. We have the input, which is to say, for this particular order, this particular item was out of stock. And then what we've got underneath it is to say, this is what we want the request. This is what we believe it should look like. And then we set up the HTTP test new server, which allows us to intercept the request. So rather than actually going to the API, we can have it hit this test code, and we just do a very quick, does what is actually going to be sent look like what we want it to be sent? And if the two things match, all is well. And then we go and run the function, and we check that to be the case. When we actually run that code under test, everything passes. We're all happy. What we gave it is what we got out. We were happy with everything. Great. We've done that first sliver. We've been able to allow a partner to say, this thing is out of stock. So now we're going to do the more interesting bit, which is this thing is out of stock, and here are the things that it's been replaced with. So the code for that has to change a little bit. So here's how the code changes. So now we can set up a slice of the items that have been added to the order by the partner. So in this case, this would be the loaf of bread that was added. And then we do the very important transformations of making this stuff uppercased. And then at the end, we just add those additions to the request, and we say, for this order ID, this product was removed. And here's a couple of things that we added to sort of make the customer happy afterwards. Again, happy with the way the code looks. We should write some tests, make sure everything's consistent here. And we kind of follow the same pattern. So here's the code for the test. In this case, we've got my bread, broccoli, and mayonnaise order. Tragically, the mayonnaise is out of stock. And instead, we've been provided the ingredients for mayonnaise of oil, eggs, salt, pepper, and a bit of patience. And then we do the same thing we did before. We say, when the function is given the data, we want the output to look exactly as the struct looks in the wanted out variable. If it does, we'll be really happy. Let's go and do that and check that everything works, which we do. We run all the tests. The new test passes. The one before it passes. Great. Everything is working really, really well. We've just now done integrated substitutions, and that is the end of my talk. Not quite. We launched code like this, and not very long afterwards, I got a Slack message from a very nice colleague, Just Eat, saying, hey, mate, could you please join this call? It looks like Jet Connect has started to call us in some weird way. Always a delight. Not great to have this happen during the lunch break either. So, okay, we're starting to send something they don't expect. That's problematic. That immediately makes us think, okay, well, what is this JSON doing then? Like, and immediately after that, why didn't our tests catch what was going on? Like, what is this weirdness that we're not seeing that our colleagues are seeing that they've mentioned to us? As a disclaimer, we absolutely did not do this deep dive on the day. We just reverted the code, and then we did the deep dive and looked into like what was going on. So what's the JSON doing then? And how have we ended up in this confusing situation where we have 100% passing tests, everything's looking good, but also we've got a production incident? Those two things don't seem to be getting on very well. So quickly after we saw that we were sending something weird, we got a bit more data about what it was that we were sending. And what we found was that when we were doing the added items, we were sending them null. And that was breaking on their side, which was the problematic component. And so the first thing we thought was, right, well, if that's the problem, we need to go back and look at the request that we're crafting. So let's do that. Let's look at the request we're crafting. Okay, so we set up the slides for substitutions. and we add the substitutions to the struct. And that for loop there only ever executes if there are any items to do anything with. Okay. And we also know or knew in that particular production instance that the requests that were failing were when there were no added items. And we thought, okay, well, isn't emit empty supposed to be our friend here? Isn't emit empty supposed to basically just handle this situation where if there's no data, don't add it? It doesn't need to do anything more clever than that. Okay, maybe that's the case. Maybe emit empty should be our friend. What do the docs say about emit empty then? I won't read the whole thing, but the point being with emit empty is that the field should be omitted from the encoding, i.e. it shouldn't appear in the JSON if it's an empty array, slice, map, or string. Fine. Go back to the code. Yeah, okay, there's no substitutions here. That slice is nil. Yeah, but the ampersand substitutions, the pointer is not nil. That's actually a value. That's actually meaningful in this context. And here is ultimately where our problem is. It's that it won't be emitted after all. It is actually there. So something's gone on that we have to kind of dive a bit more into. So we could just end the talk there and be like, well, basically the reason that we were sending null is because the types are not exactly as we thought they were working. But the more fun bit is actually to start going, having a look at what the JSON Marshal does. So that's what I'm going to do now. So we get to the JSON Marshal. If we actually have a look at what that function does, the encode state really, when you hit the Marshal function, it just kind of sets up a buffer in the background. Then we do the marshalling a little bit later, and then we write the result out to a buffer. There are actually very many sentences of documentation for the Marshal function. And fairly far in, it sort of says pointer values encode as the value pointed to, and nil pointer encodes as the null JSON value, which is exactly the problem that we faced. So where are we kind of doing that? So next, we're going to have a look at the Marshal function that's sort of called the internal Marshal function that's called. And the first block there is really handling errors. The sort of interesting stuff is the e.reflect value here at the bottom. And it uses lots of reflection to get lots of information about the way this stuff sort of works. And if any of you have ever watched the Go Proverbs talk, you know that reflection is never clear, but we will do our best with it nevertheless. I don't have a jacket that looks as good as that, but I am wearing my Just Eat hoodie today, which is very comfortable. So I sort of said, kind of interesting bit is this reflect value. And really what this is all about is finding out what kind of thing we're encoding and then actually doing that encoding. So after calling the reflect value function, we get into just a sort of single line here, which figures out what we're actually encoding. And the V here is the struct that we were sending in. So after we call the value encoder with our V that we want to encode, we're kind of sent here to this section, which then says, right, this is a value encoder function. It now then goes and finds the encoder of the type that you're trying to encode. And I've put the type there just on the right-hand side, just so that we remind ourselves, what is this V right now? And basically the V is the struct. So we then call another function, this type encoder function. When we call that function, we are essentially put into a type encoder function, which then calls yet another one to a so-called new type encoder. There's quite a lot of code here, but really the sort of simple explanation of this is depending on what the type is, it will tell you how you're supposed to encode it. And given that our V is a struct, we get this new struct encoder. And what that does is it calls yet another function that goes inside and quite cleverly goes through every field of the struct. So that would be the order ID, the removed item ID, and the added ID. And then it calls the type encoder. And it goes, for this field, find the appropriate encoder so that I know how to get the data out and put it into a JSON string. So just kind of working through that then, here we go. We've got a for loop that's going through every field, the order ID and the removed item ID. It pushes us back to this function. We get the string encoders. Then the added items, because it's a pointer, we have to get the pointer encoder. And the pointer encoder, when it is called, then goes and figures out what it is actually encoding, and it knows that it's encoding a slice. So it actually then grabs the slice encoder as well. Okay, deep breaths. We found out what we are encoding. immediately after we've called this function, it actually returns a function that we can call. And that's what this EV and opt bit is. And after you've got and you've figured out what you're encoding, now you can actually go and do the encoding. You call the encoder's appropriate function. So when we call that appropriate function, we move into the struct encoder. This is the struct that we're trying to encode. And a little bit like before, it kind of is just a big for loop. It just goes through the struct and does the encoding. We know that when we set up the struct encoder, it figures out what the fields are called, and it figures out also how you encode each of those fields. So just to kind of put a bit of emphasis on that, here is that when it's just kind of broken down into an IDE, which is quite a helpful view here. You can see that the order ID, it's got a string encoder, the removed item ID, it's got a string encoder, and the added items, it's got its pointer encoder. And every time it goes through, it just is aware of the field and how it does the encoding. Okay, so now we know what we're encoding and how to encode it, basically the point at which we can actually start building this JSON. So what we begin with is with the next byte, the opening curly, and we write that to the buffer there with the second box with the yellow arrow pointing out. Immediately following, we're looking at the first field of the struct, and so we write the string of the field, which is order ID. After that, we then call the encoder of that particular field, which, as we recall, is the string encoder, and that's the David's bread and broccoli order. That's the first loop, done. Simple. We then go through again. We hit the next of our comma. We write that down. And then we also then write down the next field, which is the removed item ID. We call its encoder, which again is a string encoder. That's the bread bit. Nice. We go again. We write the next. And now is where we get to the added items and where stuff gets fun. So added items, that field name is written just like any other. And then we call the encoder of added items, which, if you recall, is a pointer encoder. So what does the pointer encoder function look like? So here we are. This is what it looks like. You get in, you check some bits, but really what it does is, because we know that the pointer isn't nil, what it will then figure out is, okay, what am I trying to encode? And when I said before that it knows to encode a slice, the pe.element encoder is that slice encoder that's being called. So when we call that function, we actually find ourselves in the slice encoder. We know that the slice is nil. There's nothing there. It's nothing being pointed to. So we write the string null and we get out and we've done it. And this is the bit that was kind of catching us or burning us before, is that this is where the null write was happening. So now we've written the null. We return, we've done the loop, we've gone through every field, we've written every piece of data, we close it off, and we're done. If you're still with me, fair play. We're kind of at a point now then where we know why null was written, but we still haven't quite answered why did that not get caught? Why did we not see that in the test? And really, this is the sort of challenging area of like what it was that we were trying to test and how we were kind of going about it. So here is that old test. You can see there the wanted out is the order ID and the removed item ID. And then the request as it went in, now we know the problem was that it was going to write null. But the challenge that we found and the problem that we basically had was we were testing structs. We weren't actually testing the JSON that was written. And when we call the unmarshal function, which I won't go into too much depth, when the unmarshal function sees the null in the string that it would have received, it ultimately sets that value to nil. And because we know that nil for the emit empty would work, it would have hidden it from view. So ultimately, the two structs, when all of the JSON marshalling had kind of been done, would have looked the same. But underlying the strings that were actually would have been sent to the server wouldn't be. Okay, that is essentially the deep dive into the way that this happened and how we kind of found out about it. I thought I'd just kind of end on some like practical tips or takeaways or things maybe just to think about. For us, the way that we fix this First of all, in the test was rather than testing a struct, was actually to test what we were sending. There are loads of different ways to test HTTP services and communications. This is an approach that we have sort of adopted for this area. The way that the code has changed is instead of testing struct equality, we actually now test JSON string equality. So now we say, does everything match properly? And in this case, if we were to run this test, it will fail. And it will fail because it will say that what was actually sent included this added items of null, which obviously we don't want. In the handling code, you can also make sure, for instance, that you only ever add the added items if they are really there, which we've also done too. The next thing was kind of something we learned during the process of having to debug this when the production incident was going on. It was trickier to find out that we were sending null than perhaps it should have been. And so there might be a call to be said that if you can do it safely, i.e. you're not leaking any PII data and it's not too expensive, maybe log out the request that's being sent, or alternatively, maybe log the request when it goes wrong. That's also potentially an option as well. Those are only the two sort of takeaways from this. Hopefully, if it does anything, it will have people look more into the standard library, because the more I've looked into it, the more fascinated I've become with it. It is incredible, some of the stuff that is going on in that library. And it's all written in Go, which is great. So that is everything. We've talked about integrated substitutions. We've talked about how to test it. We talked about why it broke and why, and we've done a bit more on the practical stuff. And I am finished for real this time. With two extra comments. The first is just an enormous thank you to Ainsley for being very encouraging about putting this talk together, and for hearing me do a draft run of it. That was really, really helpful. And the second thing I wanted to ask was, at the end of this, I was just going to post a quick feedback form about this talk into the Go Guild Slack channel and maybe onto this call. If you thought this was useful or interesting or funny or terrible, it would be great to hear about it, because if I ever have to give a talk like this again, it would be great to just improve on the last time. Thank you very, very much for your time, and I'll take any questions if anybody has them. Back to Ainsley.
That was fantastic. It's a really good, really, really good talk. So I kind of think like the moral of the story is test the value of what you're sending, right? Or what you're doing, and multiple assertions. What do you think? Is it kind of made you think that standard library like knowledge is really fundamental when you're doing this sort of stuff? Like, yeah, can you just expand on that?
I think so, because I think a fair chunk of time was spent with surely the emit empty will do this for us, right? Surely that's going to do it, and it will work. And ultimately, the kind of challenge of this was, you just forgot what the type was, kind of. But also, yeah, knowing in the background kind of that the marshaller, it will check if it's emit empty is true, and then it will actually check that it's empty. And knowing actually what it believes empty is no bad thing. And it is just a switch statement. It just goes, what's the type, and is it 0 or is it nil or is it what? And it's like, really, it was much easier to know after just going and looking at the JSON Marshall code that was what it was doing. But yeah, I think test what you send is probably no bad approach.
Well, thank you very much for our YouTube friends. Thank you very much, and we'll see you next month.